This equation is sure to be an exact differential equation provided by the previous video on determining whether this is an exact or not. Please try to review that video because this time we're going to focus on solving for this sure to be exact differential equation. To start, of course, this is in this form: m of xy dx plus n of xy dy equal to 0. With this, we can identify m of xy and n of xy. We need this because in our processes later, they will be used as well. M of xy is a function paired with dx. You have 2xy squared minus 3. And our n of xy is the function paired with dy. You have 2x squared y plus 4. Now, the solution for this given exact differential equation is identified as f of xy equal to c. This is the solution. And how do we solve that? We need to start with f of xy. Okay, f of xy can be solved in this formula. You have m of xy dx plus g of y. Okay, so simply plug in m of xy here. You will have the quantity 2xy squared minus 3 dx plus your constant g, not constant, function g of y. This is not yet identified. That's the next step later once we are done with this, because we need to solve that function in terms of y. Now, we can always take this here. You have 2xy squared dx minus, you have the integral of 3 dx plus, of course, plus g of y. I usually do this on my classes. I just remove or move out the constant so that it will be easier for me to integrate. And that's actually part of our processes before. Now, let's remember that we are integrating in terms of x. So this y squared here is not part of our, it's just a constant. So together with 2, you can always bring that out because we can always bring out the constant. You will have integral of x dx. We're able to move that y out because we are treating that as a constant in this case. Similar here, we have 3 integral of dx plus g of y. Of course, you will have 2y squared here still, and the integral of x dx is x squared over 2. Supposedly, there should be plus c, but let's just leave it later, okay? And minus 3x, the integral of dx is just x, plus g of y. So, to finalize this, your f of xy, canceling this, you have x squared y squared minus 3x plus your function g of y. As this is already the solution, we are almost done. We're saying almost because there's still g of y that needs to be really expressed in terms of y. Okay? So how do we solve g of y? We need to use the idea that the the partial derivative of f with respect to independent variable y. So that would mean the partial derivative of this, you'll have x squared y squared minus 3x plus g of y, the entire function with respect to y. If we have y as our independent variable, that would mean x here will be treated as constant together with 3, and x squared here will not be integrated, but it will be left as a constant. Okay? So what happens then here is this. You have, of course, we'll be leaving x squared as x squared itself, so you have x squared here, times, you will have to derive this, so you have that's 2y. Of course, again, this is only has x, so that's minus 0 because we're treating x as a constant. Plus, the derivative of g of y is actually g prime of y. Okay, so you will have here 2x squared y plus g prime of y. That's your partial derivative of x with respect to y. Why do we have this? Because the partial derivative of y, f with respect to x, is just equal to your n of xy already identified earlier here. This was our n of xy. So, equating them, you'll have 2x squared y plus g prime of y, that's our partial derivative of f with respect to y, is equal to your n of xy, 2x squared y plus 4. So you have 2x squared y plus 4. With this, we can now solve g prime of y, as this is on the same side, both sides rather, you can cancel that one. So your g prime of y is just equal to positive 4. Okay? So it's just positive 4. But since we're looking for g of y, not g prime of y, let's integrate both sides. dy. You will have your 4 dy. So this returns to g of y, the thing that, or the function we're looking for. Of course, you will have 4 integral of dy. You will have 4 y here as our g of y. So this is our g of y to be substituted in this result earlier, which corresponds to our solution. So x squared y squared minus 3x. That's our f of xy, x squared y squared minus 3x plus g of y, which is this. So this is x squared y squared minus 3x plus 4y. And this is now the answer. But of course, you will be expressing it in this form. Let's just express in this form. Your function is equal to your constant c. And this, since this is your function, just simply equate it to c, x squared y squared minus 3x plus 4y equal to c. And this ends the process of solving this exact differential equation. So as a recap, since we are sure that this is the exact differential equation because of the previous video pertaining only on that, we go back to m and n because they are needed here. You have this form because this is the solution. Solve for the function, you'll be having g of y. Use the partial derivative of f with respect to y as this is the equivalence. Once you're done with that, you will get your g prime of y. Integrate both sides to get your g of y. Return to your function solved earlier and equate it to c, and that is the end of the process. Thank you very much for watching.